Just let me know when you're ready for me to move it up. Seriously? Okay. Should have given you the blank piece of paper. Okay, let's see. Okay, Kaylin, right? Avery? Yeah, what's going on, Abby? You can do fractions. I love fractions. Whichever is the most comfortable for you. Anna? Wait. Anna's over there. Yeah. There you go. Yeah? You want a calculator? I've got a few over here. Here. Did you have a question? They're both fractions. Oh, you don't need this, do you? You like fractions. I like fractions too. All right, see you now. Oh, you want me to scroll now? Okay, okay. Karen? Karen? Sorry. Joshua? Hayden? Yes, Oz? No, I don't start until 50. I didn't start before 50. No, I didn't. Good thing I started early. Okay. No, I will not mark you tardy. And even if I do, what does it matter? Yeah, what does it matter though? I mean, it's not going to do anything bad. Yeah, I will not. Okay, I promise I won't. I will not mark tardy ever. That's fast. There you go. Is that calculator? You ready, Sienna? All right. There's that. Okay. Oz. Carson. Yeah, there you are. Caleb. Caleb. There you go. You can do it. Is it in Spanish or is it in it's English? Does it help? Yeah, all right. I need to do one for French. Yeah, well. Kirsten. Enjoy. Trinity. Oh, there's another Abby. All right, excellent. Well done. All right, no hurry. It's there. Do you want me to take this off your hands? Sure, why not? Get rid of this stuff. What do you think? This okay? Take this. Is that okay too? I mean, I could change the grade if you prefer. All right, you're all set here. Wow, the whole row. Good job. All right, Dante. That one? You okay? I'll figure that out for copy. Okay. Thank you. All set? What do you think? You look so excited. You're all set? All right. Yeah, I don't want to take it if you're yeah. Some people like to draw on the back. This row's all set. Yeah, I know. Well, I was just going over there to get hers. It's okay. Thank you. All right. Thanks so much. Good job. See, all set here. You guys all set? Is this for me or for you? Oh, nice, pink. I like it. I always have to change the color of the pen that I use to grade based on you. No, it's fine. You can use whatever color you like. I'm just going to put it on top so I remember. Yes. Well, whatever the perception is, there might be something weird with relativity going on in time. I don't know. All right. Sorry to give you, when you're ready, you just let me know, okay? I know you were at a disadvantage, so that was my fault, though, so not yours. I think you're the only one, though, but take your time. All right, so I think I figured out what happened is that someone added, and I have the number of students in each of my classes up on my wall, so I know how many quizzes to print, and I based it on the old number. So I'll make sure I update that so that I can get the right number in the future. So we'll just wait another minute or so, and then we'll go over this quiz. So I apologize for my mix-up there. This will give me a chance to mark everyone present, though. I won't mark anyone tardy, promise. Attendance. 1, 2, 3, 4, 5, 6, 7, 5, 4, 8, 12, 4, 8, 13. Yes, everyone's here. Okay. Beautiful. You know it's right when you get that one up there, so good job. All right, all right. Did you have your name? Put your name somewhere. Yeah, just say SJ or something. Just, yeah. And if you want, you could do the other side as well, but I don't think you do. It's differential equations. All right, I got them all now. Sorry about that mix up with the number of quizzes. So here, let's just quickly go over this, and then we'll move on. So the first one, let's see, we can argue about this. So we remember, experiment is where the experimenter has some sort of, they're manipulating something about the environment or about the thing. So this one is an experiment because, because we are printing. So this is the color of the test. So some people get one color, some people get another. You could also do this with, technically, I guess you might claim this isn't controlled because the control would be a white test, but we could do that. You could say, okay, one of them is white, but what have you. Then football coach, this one is sample of recent, yeah, so this one's observational study for sure. Yeah, this one's observational study, it's a survey, so there's that. Oh, by the way, this first one, I think I mentioned, maybe I didn't. Oh, I mentioned the idea of having a calculator available to you, that even if you can't use it, like having a photograph of a calculator actually improves scores, at least according to one of my colleagues who did this experiment back, well, this would have been 20 years ago now. Okay, so, but color of test, that's something that I've had colleagues do, you know, to see if the color of the test, and it does seem to affect the grade. Different colors, yeah, have a slight change of grade. So I try not to do that. I don't do different colors. Anyway, back to this. This I think is 5, is that right? If you add up all of these, you get 20, and there's supposed to be 25 pencils. And then relative frequency, you could either do it as 1 out of 25 or 0.04. This would be 0.08 or 2 out of 25. I'll just write this as 5 out of 25, 11 out of 25, etc. And then over here, you just add up the total. So this will be 3 out of 25 because it's going to be the 2 and the 1. And the next one will be 8 out of 25, which is the same as 32.32. Is that right? I think so. So anyway, you can fill in this. And if you've done it right, you'll have a 1.00 or 25 out of 25 down here. All right, good job. Let's move on to our PowerPoint for today. So, oh, and I should warn you that today we're going to do this by hand, but then on Wednesday we're going to do it with Excel. So I saw on your, thank you for doing the survey, by the way, and I saw that most of you have good computers. There's at least one of you, or at least I guess I should say there's exactly one who admitted that the computer that you're using for class is going to be an iPad. That's okay. It's not the best, but we'll overcome that. There are going to be a few things that are going to be difficult for you if you're the iPad person. I do have an iPad up here, so I know whence I'm speaking. But anyway, the graphs, we want to make pictures of data, and I'm sure you've done this. I think I mentioned numerous times that my kids would come home with various things that looked like art projects, but were really supposed to be some sort of a math or science results from a survey. And basically a chart. And so today we're going to look at histograms and try to deal with the nuances of a histogram. You probably already know how to do this, but nonetheless, we're going to go ahead and do it. And so to do a proper histogram, what we're going to do is we're going to make a grouped frequency distribution. These are the actual numbers that you gave me when I asked you the question, what year was the first Macintosh computer first available for purchase in the United States? So we'll look at this. I'll tell you what the answer is in just a minute, although you can Google it if you want to. So these are the answers that you gave. And I suppose that any one of these is good because it was before you were born. And so pick a number, right? It doesn't, like, I remember things that happened before I was born. It's like, yeah, sometime a long time ago. So anyway, let's go ahead and group these together. So notice that the lowest number is 1950. I think because was that the lowest number that I gave you as an option? It might have been. So the lowest number is 1950. I wanted to make sure that everyone had a number that was in a certain range. That's the only reason I did that. And I think the highest number is 2003. And so if I was going to group these together, one logical thing that you might say is group them by tens, right? Put all the 1950s together, then all the 1960s and the 1970s and so on. So that's one logical way that you might do this. And so, so here's one thing that we can do to make this easier on ourselves is to, first of all, sort the data into, from smallest to biggest. So here's the data that's been sorted. And now I'm just going to copy this so that I don't have to write on PowerPoint. Give me just a minute. And then we're going to group these together. It's not going to be too difficult. So here we are back here. Okay. Let me see, can I paste it? There are my numbers. Okay, so as I mentioned, I'm going to group these and let's see. Sorry, I just want to, let's do it. Let's do it the way that we would do it, and then I'll tell you what Excel did for me, okay? So the way I would do this is I would say, okay, I'm going to do 1950 up through 1959 is going to be group number one. 1960 through 1969. And this isn't exactly what Excel did. So that's the main thing. With Excel, the issues that we're going to bump into is that we're going to have to sort of manipulate it to get it to do what we want it to. So I'll show you, I've already prepared the histogram for the Excel thing. It's not exactly this. So 1970, all the 1970s. And notice there's a couple of things to notice about these. I've got these groupings so that every number will fit into one of the groupings and none of the groupings overlap. And finally, all of the groupings are the same size. We want them all to be the same size when we group these things together. 1980 to 1989, 1990 to 1999, and then 2000 to 2009. So there are my groupings. So here's the groups, and I want the frequencies. Well, of course, now that I've got it sorted, all of these data sorted, simple, we can just count these up, can't we? So you have 1950 through 1956. So 1, 2, 3, here, I'll just check them off. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 in that grouping. And then there's 2 in this next grouping. And then I'm seeing 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 in that grouping. 1, 2, 3, and then 2 in the last grouping. So there's my grouped frequency distribution. Once you have that grouped frequency distribution, the last step is to draw the histogram. Now, well, actually there is one step between drawing the histogram and doing this, and that is that we want to come up with some sort of a boundary, some boundary between the groups. Now here's the key, is we want the boundary to be bigger than, so here, just as an example, I want a number that is bigger than this group, but smaller than this group. So the boundary that I might use is 1959.5. So that kind of sits in between those two groups. You could do the same thing here. Find this boundary by just taking this 1969 as the biggest number in that group, 1970 is the smallest number in that group, so 1969.5. So those are going to be my boundaries that are going to help me draw my histogram. Once again, what Excel does is slightly different than this, so I'll explain the difference, but I want to make sure you're ready for when we do this with Newton, so that you're okay with that. So we don't need our Excel right now, so you shouldn't, or are you taking notes on this? Okay, yeah, you don't need that then. So yeah, you should be drawing a histogram at this point. But on Wednesday, we're going to definitely use Excel. So that's when you'll want to have your computer. Make sure Excel is installed. By the way, if you feel like your computer's not up to the task of using Excel, you can always borrow a computer from the library. And if there are issues, that's something that I will suggest, especially for iPad person, eventually maybe. We'll see how things go. Anyway, yeah, actually, yeah, iPad person, I might email you. I'll have to dig you out of the list here. You might want to borrow a computer if you don't have one that like a Windows or something. But anyway, getting back to this, now that we have our boundaries, you're going to set up your axes. So those axes, you're going to put those boundaries on there. 1969.5, 79.5, 89.5, 99.5, and then 2000. Okay, 2009.5. Good enough. Okay, and then the bars, of course. I know this is very babyish because you've all done this back in elementary school. But I want to point out a couple of things that always cause problems. That if you're making a histogram, one of the things that you want to focus on is that the bars will touch one another because this is continuous data. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this bar goes up there, but it goes all the way. It spans the entire range of values. And you might say, well, wait a minute, 1969.5 isn't in my data. Yeah, but this way we can sort of say that we've got everything covered, the whole range, including all of our data. So there's 9 there, 1, 2, 3, 4, 5. Let's see, 2, we'll go up to 2. The rest of this is pretty straightforward. Then you do this. So notice that there's no gap, no gap. If you're making a bar chart, you will have gaps. So bar charts usually are used for qualitative data, histograms for quantitative data. Okay, 6 goes up to here about, so no gaps. And then, oh, I feel like I've missed something. What did I miss? Hold on a minute, 59, oh! 49.5, I'm off by 1, crud. Just a sec, I can correct this easily up here, but you might have a little bit harder time there. So there it is, 1949.5. So that first grouping, I forgot about the lower class limit or the boundary for that first grouping. Okay, so I'm up to, let's see, 6 and then 3 and then 2 for the last one. Okay, good enough. So you could even put numbers up here if you want to. So pretty straightforward. But like I said, it does cause a little bit of grief when you're trying to make a histogram. And this is descriptive statistics. I'm not Yeah, I'd like to get on to the other stuff, but we need to talk about descriptive statistics so that we can do inferential statistics. So any issues, questions, how we got this? Got your grouped frequency distribution, put it all together. Okay, let's switch back to PowerPoint land, see what we've got. Okay, so differences with Excel. Excel decided I realize now I should have, but I could have forced Excel to use the groupings that I had, but here's what Excel did. Excel did from 1950 to 1960, and then 61 to 70, 71 to 80, and so on. So when you see the graph, it's just slightly off, and the main difference will be that this 1970 will be in it'll get shifted down a bit. The 1980 is in the lower grouping instead of in the grouping that we put it in, and then the 2000. So all of those boundaries got shifted when Excel did this. I could have forced it. I should have thought ahead. I didn't think of this, but here's what they have. And notice that this also bothers me, is that the lower grouping here goes from 1950 to 1960. That includes 11 years. If you count it up, you get 11 years. Whereas this, from 1960, this open bracket means it doesn't include the 1960, so it's 61, 62, 63, and so on up to 70. That's only 10 years. So that bothers me as well. But on Wednesday, if I had, well, rather, yesterday when I was doing this, if I had cared enough, I would have fixed it, but I didn't apparently. But on Wednesday, I will show you how to fix that. So we'll get this to look just like our histogram, but we'll do that on Wednesday. So I'll use these data on Wednesday. So I'll provide this to you. I will upload it, and you will be able to download it on Wednesday. Okay, onward. So how many siblings do you have? This mainly, I just want to show you the difference between a grouped frequency distribution and a non-grouped. And that looks terrible with that siblings and frequency. But we'll hopefully can overcome that. Anyway, so here, when I ask you how many siblings do you have, that would be a question that would be answered either 0, 1, 2, 3, and so on. So you wouldn't be grouping, yet you could still draw a histogram, and we will. I believe this is one of the questions we had on the survey, so I won't ask you again, so we don't have to do that. In this case, how old is your maternal grandmother? I'm not going to ask you to try to figure it out. I don't know how old my maternal grandmother is. I can't even remember the year she was born, to be honest. I think, well, she's dead for one, and yeah, I don't know how old she would have been if she was still alive. I think she was born in 1921, maybe. So then I could probably figure it out. But let's say that we could figure out, if you knew your maternal grandmother's, that's your mother's mother, your maternal grandmother's age, then a possible set of groupings. Unlike here, you've just got siblings. It's either 0, 1, 2, 3, 4. Here, whoops, not how much money. For age, you might have the groupings be between, it depends on what's the youngest grandmother. I think probably for someone your age, the youngest a grandmother could be is about 45, 50. I know that's ridiculous, but I'm just trying to think, like, what's the very youngest? I think I was speaking to a student last year I had who had a grandmother who was under 50. So it is possible. So let's go with 45. So we might do something like this: 45 to 54, 55 to 64, 65 to 74, and so on. So this is one possible grouping. There's other groupings that you could do, 75 to 84. So once we have that grouping, as I mentioned earlier, one of the things that we're going to do is come up with our class boundaries or limits. Let me see, what am I calling these things? Boundaries. So I need to know the number between here. What number goes between each of these? So let's go ahead and compute that, and then I can start randomizing you. So pick a number between, I guess, that goes first to this first grouping right here. So you can discuss it with your neighbor if you're unsure, and I'm sure that they will help you. Well, Anna, do you have a good number to slip in there somewhere? It's perfect. Yeah, 54.5 works because it's neither in the previous group or the next group. So it's somewhere in between. Very nice. And we should be consistent. So now that Anna's set the bar for us, let's just get another one and then I'll fill in the others. Carson, what would you like for the next boundary? Yeah, 64.5. Technically, you could use any number in between 54 and 55, like 54.7, but why make it hard on yourselves? I think Newton always just splits the difference between the numbers and gets 54.5. And of course, the next one is 74.5 and 84.5, and I need to not neglect that one. Now that we've got those, you can kind of work backwards, and you might, whoops, 44.5. You might say, why do we need that? Well, it's because of the whole histogram, drawing the bars, knowing where the bars go, blah, blah, blah. So that's the way that's going to look. So here's just some terminology, and then we'll get to some other stuff, I guess. Oh, I know, Newton. I wanted to show you something about Newton. That's it. So I was looking on my PowerPoint, like, where is the rest of the stuff? It's on Newton. Anyway, getting back to this. So when we're looking at a grouped frequency distribution, I've already used these terms, but let's go ahead and make sure that we've got them nailed down. We're going to be referring to things like the lower class limit. Lower class limit is the bottom of each group. And then, of course, you probably can figure out that the upper class limit is the other side. So the upper limit of all those groups. Notice that in each case, you're counting by 20s. Sorry, these are 20s. So you're always counting by the same amount. So it's counting by 20s there, and then here counting by 20s. So lower class limits and upper class limits refer to those numbers. And then we compute the class boundaries. The class boundaries are these numbers that are going to slip in between. So in between the different classes, and don't neglect that first one the way I did, because it'll mess you up. But anyway, so in between, and in order to be consistent with Newton, just divide the two. So you have 69 and 70, split the difference, and you'll get that number there. So those are the class boundaries for this. There's one more thing that, that we're going to be interested in that might be useful, and that's class midpoints. I'll just give you a minute because I know some people like to copy everything down, and that also gives me a chance to pull up my Newton, which I was looking at earlier, but I didn't get the particular thing set up. So let's see. For homework, here it is. There we go. Is this it? I'm just looking for, oh, there it is. It's going to let me do this. It's not. Well, I'll just show you this then. But anyway, well, maybe I'll just, so let's go ahead and move to class midpoints. I'll bet you can guess what the class midpoints are. They're the middle of those bars. So for example, if you take 50 and 69 and average them together, you get 59 and a half. That's the middle of that particular class, that group. Let's see. All right, cancel this. Okay, so last thing, and then we'll be done. A little bit early. You can go get another omelet from the cafeteria. Give me a sec. Or you can stick around and we can chat. So here's just a preview of, let's see, let's cheat on this one. I know you wish you had that button, but you don't. Let's see, I just have to find these are all pretty straightforward. They're simple questions that they're going to ask you about histograms, but there's one question in particular I want to make sure I preview with you, and it's probably not going to give me an example of that. Oh, give me a break. Give me a sec. Let me try again. Let's see, preview. So apparently you might not get this. This is one thing that is annoying to me, is that you sometimes don't get the exact same types of questions that I get. One more try. And then if it doesn't get it, I'll just show you in the, I don't want the static version. Whatever, instructor, cheat, good, boring. Okay, finally, good. Okay, so this one. So every now and then you'll have problems like this that you have to do in Newton. Some of them are more annoying than others. This one isn't too bad. Where they get annoying is when they have you shift things down here on the x-axis, but they don't have you to do that in this particular problem. So when you get to this problem, essentially what you're doing is you're just supposed to create the histogram, which really isn't all that tough. You're going to make the first bar 1 unit tall, or whatever it says up there. So that's easy enough. Click and drag, and then click and drag this one. So that's pretty much it. I just wanted to warn you that you have this sort of thing, and you'll have to manipulate as best you can your little thing. There are some in the future that we will have to do. Wait, I think I got one of those wrong. Is that right? 11 and 10. Yeah, that looks good. So in the future, like I said, there's going to be some of these that we have to deal with where it's more annoying than this. It's going to be hard to do. And so when you get to those, just I'll preview them just like I'm previewing this one. Okay, so a couple of things coming up. Just to remind you, and then you're going to go get your omelet. Bring your computer on Wednesday. You're going to be working on your project this week, which is just to pick a data set. I had someone come up before class. We have time now if you want to talk about your particular data sets now. So you can stick around and we can do that. So that's coming up. And then next week, not this week, next week is the first exam. And so when that comes, I will give you a practice test. We'll have plenty of time, and it'll be similar to these quizzes. So if you're doing well with the quizzes, you're going to get an A on the test. All right, stick around if you want to chat. I'm going to stop the recording so that